Alright, so in this problem we're asked to find a midpoint Riemann sum to estimate this integral with 4 subintervals. So the first thing we need to determine is what is our delta x going to be. So delta x is always b minus a divided by n. And we know that in this case, b is equal to 3, a is equal to -1, n is equal to 4. So if you plug all that in, you'll get that delta x is just equal to 1. So that's actually relatively simple. And then xk is equal to a plus k times delta x. And so if we plug in what everything is, then this is -1 plus k. But now remember, this is not really what we want because these are the left and right hand points. We now have to figure out what are the midpoints for these subintervals. So to do that, we have to average the left and right hand points together. So we have to find what is xk plus 1 plus xk divided by 2. So if we just calculate this by plugging this thing in, we'll have -1 plus k plus 1 plus -1 plus k, all divided by 2. And if we do some simplifications, looks like we get 2k minus 1 divided by 2. So let's see. Now that we have our xk mid, we can try to write down what is the general form for our Riemann sum. It's going to be a sum f of xk delta x. Let's think about what our indices have to be. If we plug in k equals 0, then we'll get -1/2 here. So that will be the first midpoint that we encounter. So we want to start at k equals 0. And then since we have 3 pieces, we go up to 3. Or sorry, 4 pieces. That means we go up to 3, right? 0, 1, 2, 3. Then we have to plug in the information that we know. F of x is equal to e to the 1 over 1 plus x squared, and we have to plug in xk mid. I should specify that. So we plug 2k minus 1 into our function, and we get a sum from 0 up to 3, e to the 1 over 1 plus 2k minus 1 over 2, all squared. That's our f of xk. Then we have to multiply by delta x, which is just 1. So in the end, we just get the sum from k equals 0 to 3 of e to the 1 over 1 plus 2k minus 1 divided by 2 squared. And that would be our midpoint sum using 4 subintervals.